What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are continuing what we started late last night, which is a walkthrough of the official digital PSAT from the College Board. So this is Module 2. So for those of you guys who are not familiar, sorry, just checking the audio. For those of you guys who aren't familiar with the new digital PSAT, it's different than the previous versions and of the regular PSAT. And the reason why is obviously, number one, it's all digital. Number two, it's all calculator. Number three, it's split up into two modules. And both modules are the same length, but they are adaptive. And module 2 is the harder module. And the difficulty of module 2, right, depends on how well you do on module 1. So if you've done really, really well on module 1, we're going to get the hard version of module 2, which I believe I got 100% on module 1. I haven't checked it yet, but I'm going to check all that today. And we can see if I made any mistakes, and I'll go over them. And that's about it. I want to let you guys know that next week, leading up to the SAT, obviously we're going to be doing a stream every day, so that's going to be really fun. I'm going to get you guys prepped and ready for the October SAT. That's a really big date. I highly recommend you take the October SAT as well if you're taking it in this fall, early winter time. The reason why is because for the October, you actually get the full test back. So you can see exactly what questions you got wrong, what questions you got right. For those of you who took August, you'll notice you don't actually get to see the test. And that's really unfortunate because you can't learn from your mistakes or see your specific weaknesses and strengths. So definitely take this October SAT if you can. All right, one last thing. We have entered into a partnership deal, and so this video is indeed sponsored. It is sponsored by, sort of sponsored. There's a company that we've partnered with. It's called SAT Crash Course, and they have amazing, we're about to change to the full digital SAT. They got digital SATs, digital PSATs, and you can buy them, and if you do it, you can use the link in the description below and use the code SCALAR, all caps, SCALAR, and you'll get a discount if you do that. I have partnered with them because I truly find them to be a remarkable product. I've taken one of their sample tests and I really liked it. And it's hard to hit it on the money and to get a really good, authentic feel for what the College Board does. I feel like they've done a really good job. I like the platform. I like the entire thing. And so that's that. I'm going to be taking one of their PSATs as well later in the week. And next week, I'm going to be taking one of their SATs as well. So you're going to get that exclusively on this channel. And it's going to be really, really cool. So anyways, check them out. See what you think. Give it a go if you're looking for more practice materials. All right, great. Without further ado, let me take a sip of my coffee. Without further ado, we are going to jump into Module 2 of this PSAT. So we're going to resume it. This is always a lot of fun for me. We got a little whiteboard here. I'm going to get Desmos up as well for the calculator. Again, the entire test is calculator. So that's pretty cool. All right, here we go, ladies and gentlemen, taking it in real time. I normally say first time. I think I have done this with a student. I can't remember if we did the entire digital PSAT already yet. I know we did module 1. So anyways, maybe for the first time, may not be, but it's been a while, even if it has been. So it'll feel like a fresh attempt. Okay, here we go. 3, 2, 1, let's go. A little bit of time has gone off, but we're still good to go. Cleaning service that cleans both offices and homes can clean at most 14 places per day. So both offices, which inequality represents a situation where F is the number of offices, H is the number of homes. So at most 14. So that's less than or equal to. And I would say the sum, right? Because it's at most 14 places. So if I did 3 of those and 11 of those, I'm capped out. So we're adding them together, less than or equal to 14, boom, done. Number 2, in the given equation case, the equation has infinitely many solutions. All right, if it's got infinitely many solutions, that means that they have to be the exact same on both sides, meaning K must be 21. It must match that constant. If it said no solution, it could be anything but 21. It could be 20, 19, 18, etc. Number 3, the y-intercept of the graph, boom, 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 is 0, y. All right, so what are we going to do? Well, we got a beautiful equation there. I'm going to write it out. 12x plus 2y equals 18, and they're telling us that 0, that's the y-intercept. So plug and chug, 0, that goes away. 2y equals 18, divide by 2, y equals 9. The value of y is 9, boom, done. Double check, plug in 0 and 9, 18 equals 18, boom, done. Number 4, wait, did I enter it? Yeah, we're good. The graph shows the height above the ground in meters of a ball x seconds after the ball is launched outward from the platform. Let's take a look at the graph. So here's the height, here's the time, boom. Which statement is the best interpretation of this point? 1, 4.8. So we're going to answer this before we look at the answer choices, which I love to do on these problems. Look, it's saying at 1 second, the height of the ball is 4.8 meters. That's what it's saying. Now let's read the answers. 1 second after being launched. Look at that. Beautiful. It's right there. And here's the platform. It's a platform of like 3.8 feet. 4.8 seconds. No, wrong. The ball was launched from an initial height of 1. Wrong. The initial height I already told you is the y-intercept, 3.8. The ball was launched from an initial height of 4.8. Wrong. That's not even the right initial height. So A is the winner. Boom, done. 5. Based on a random sample from a population, researchers made the mean value of a certain variable population 20.5. Okay, so immediately when I see margin of error problems, this is what I do. Margin of error means plus or minus whatever that value is, which means if the mean is 20.5, margin of error is 1. It could go as high as 21.5, as low as 19.5, plus or minus 1. And now let's go. We should see those numbers. Okay. It is, okay, every value of the variable in the population is between. So this is obviously makes no sense. And it's definitive language that should make you suspicious. No, that's not what it's saying. It's talking about the mean. It is not possible with the mean value. Wrong. Oh, sorry. Meant to cross it off. My bad. It is not possible with the mean is less than 19.5. It's not that it's not possible. It's just, you know, very likely that it's in this margin of error. It is plausible that the actual mean value of the variable of the population is between 19.5. And I would say yes. Actually, wait, this is a little weird because the mean, okay, so it's definitely not this. The only thing is, well, we should never say it's not possible, but the margin of error is meant to encapsulate, like the possible variations. So it's, part of me is actually thinking it might be B, but I feel like it's just such definitive language. It's not possible with the mean value for the variable of the population. I just feel like that's just too definitive because you're always taking the sample. So even the margin of error, it can't be I would have to say A, but let's see. I could see that being wrong, and if so, we'll go over it. Table shows the frequency of the values in a data set. What is the minimum value of the data set? It is 19. That's it. Just reading a table. That means there's 7 19s, 1 21, 7 23s, etc. But the smallest value is 19. Next, the given equation, and we got to go faster. I remember module 2 is always harder. So the given equation relates positive numbers in which, okay, this is an isolating quantities question. So all we're doing is, you can see in everyone, we're isolating n. So we got 7m is equal to 5. I'm going to distribute it. 5n plus 5p. We're going to minus 5p from both sides. Boom, equals 5n. Divide both sides by 5. Divide both sides by 5. n equals 7m minus 5p over 5. Oh, it's B. Okay, so it's B because what they did is they broke it up into 2 pieces. It's 7m over 5 minus 5p over 5, which is just p. So B is the winner. Boom, done. Number 8. For the given linear function, which table gives 3 values of x and their corresponding values of f of x? Okay. Oh, well, it's just f of x equals 39. So all the function values should be 39. And regardless of the x values, it's got to be B. Yeah, no, it shouldn't be a 0 in there. Shouldn't be a 0 in there. Shouldn't be a negative 39 or a 78. So B is the winner. Boom, done. 9, a rectangle. Okay, they're talking about a rectangle. What do I say? Always draw it out. I don't care how easy you think it might be. A rectangle is a length that is 15 times the width. There's the width. Here's the length. Where y is the area in square. Oh, look at that. It did it exactly the way you said it. Y equals this represents the situation. Y is the area in square feet. Which of the following is the best interpretation of 15? It's the length. That's it. Because they said the length is 15 times the width. So 15w is the length of the rectangle. Boom, done. Number 10, table gives the number of hours. Let me move this. Oops. Let me move over. Table gives the number of hours, h, labor, okay. There's a linear relationship. Immediately when I see that, I'm writing these as coordinates. Boom, boom. 3, 2, 85. And they want the equation. That's it. Beautiful. So we're going to use this to calculate the slope first and foremost. You can use a calculator if you want, or mentally if you're really confident. 155 minus 285 is negative 130. 1 minus 3 is negative 2, right? Subtract down. That's why I like to stack the coordinates so you don't get confused on the ordering. So that is 65 is the slope. The only one with 65 is C, but we're going to double check it. We're going to say 65h plus 90. So we're going to plug in 1. That gives us 155. Corroborated. Plug in 3. That gives us 195 plus 90 is 285. Double corroborated. Boom, done. 11. Which expression represents the result of increasing a positive quantity W by 43%? Okay, this is, again, going to write it out first. It's multiplying by 1.43. The other way to think about it is W plus 43% of W, but these two are equivalent. A is the winner. That's how you do it. And by the way, just to say, if they say an increase of 43%, you multiply by 1.43. If they said a decrease of 43%, you minus that from 1. So you'd multiply it by 0.57. That's a decrease of 43%. That's increase. Okay. Number 12. Here we go. The shaded region shown represents the solutions to which inequality? Okay, let's first get here. We're going to do this. I'm going to take a screenshot, pop it over here, and let's analyze it. So we got a y-intercept of 1 and a slope of, that looks like negative 4 over 1, negative 4 over 1. So negative 4x. So negative 4x plus 1 is a slope-intercept form, and its y is greater. Why is it greater? Because if you look at it, it's vertically above. We're shading above, right? Don't think left and right. Think above or below. So it's above, greater than. Why not greater than or equal to? Because the line is dotted. So y is greater than, it's this. It's negative 4x plus 1, or they just reversed it. So, I chose less than. Oh, my God. Y is greater than. I almost made a mistake. So you got to double check. Y is greater than negative 4x plus 1. Just make sure I didn't make a mistake. Okay, we're good. 13 was the positive. Okay, nice little star method situation. See, they do the star method more on the digital than they used to. It's very interesting. Okay, so I'm going to show you how I solve one of these. Star method, A, which is the 5 up here, B, which is the negative 37 down here. A times C, 5 times negative 24 is negative 120 up top. What two numbers multiply negative 120, add to negative 37? It's going to be 3 and negative 40. Because that gives you negative 120. They add together, give you negative 37. Then we reduce like fractions. That becomes 1. That becomes negative 8. Here's our coefficient, or numbers for the factory. So that's 1x minus 8 times 5x plus, plus 3. So the solutions would be negative. This one would be negative 3/5. This one would be positive 8. They want the positive 8 is the winner. We're going to plug and chug just to double check. I think we got the time. 8 squared is 64 times 5 is 320 minus, that's 240 plus 56, 296. Hold on, what did I say? 64. I said 320. I'm going to use a calculator. Darn it. Okay, so it's 5 times 8 squared minus 37 times 8 minus 24 should equal 0. It equals 0. Boom, verified, done. By the way, so if you forget to factor, you can lean on your calculator, plug and chug, and see which one of these works, because only one should work. Okay. One side of a flat board has an area. Okay, hold on. They're talking about a board. Let's make a rectangle. All right. One side of a flat board has an area of 874 square inches of a pressure of 19 pounds. 19 pounds per inch is exerted on this side of the board. Oh, yeah. This is just a proportions question. We need down here. So it's pounds, inches, 19 pounds per square inch. And what is the total force exerted on the side of the board? So then it's 874 square inches. By the way, this is inches squared. And x. Okay, so it's basically just 19 times 874. 19 times 874. In total force in pounds, 160,606, 5 characters. Yeah, okay. Just double checking. I'm like, that's a big number. But it's allowed. Because you can't do that on the current version of the SAT. It's too big. You can only do 4. But here you can do up to 5. All right, 15. Let's keep it going. So you guys might notice this module 2 is harder, right, than module 1. You can feel it. One of the two equations of the system of linear equations given the system has infinitely many solutions. What does that mean? That means the two lines are exactly the same. So immediately what I'm going to do is I'm going to simplify this. Divide everything by negative 5, or just 5. Negative 3x plus 5y equals 13. And this is the core simplified version. So now one of these has to be a multiple of this. So let's see. If I take this and I multiply by 4, I get C, which means it's identical. So C is the winner. Just double check this one. Yeah, the 13 shouldn't, this negative 52 should be positive in this case. Here, if the 12, they're not both positive, that wouldn't make sense. 12, yeah, they can't both be positive, right? Because if you multiply by negative 1, you'll flip this one, but you'll flip this one as well. So C is definitely the answer. By the way, if you want, here, I'm going to show you how you double check this. Watch this. Another way to do this, if you don't want to do it that way, if you want to go straight up calculator, I'm doing this because I think I got the time, so hopefully I'm not wrong about that. Negative 12x plus 20y equals 52. You look and you see infinitely many solutions, meaning they're right on top of each other. You see that? So that verifies it. Okay, next. A bus traveled on the highway and on local roads to completion of 160 miles. The trip, okay, let me just write this numbers down, 160 miles. And then the trip took 4 hours. The bus traveled at an average speed of 55 miles per hour on the highway, an average speed of, gosh. Highway. This is so bad here. Let me organize this better. 4 hours, 55 miles per hour on highway. And, they can tell us this. Highway is X. Let me keep it consistent. And then 25 on local roads. Y is the time in local roads. Y on local at 25 miles per hour. And distance equals rate times time in the equation. Okay, which system of equations represents the situation? Okay, hold on. Tip 4. So X and Y are the number of hours traveled on each, which means X plus Y equals 4. We know that. So it's not this one, and it's not this one. It's one of these two. And then we already got it. 55 times X plus 25 times Y. Here they flipped it. 55X plus 25Y equals the total miles, because rate times time equals distance, 160. Rate times time equals distance, 160. So we're adding them together. B is the winner, done. 17, here we go. Let's see. Graph shows momentum in, I'm trying to read around the mic. Graph shows momentum, actually, hold on. Let's pop this over here. Okay, the graph shows the momentum, y newtons per second object started moving from x 0 to 8, 0 to 8, boom, boom. What is the average rate of change in newtons? Okay, from 2 to 6. All right, average rate of change. All you're doing is you're making, it's so small. You're going this point at 2 and this point at 6, and you're making a line. Okay, that's all you're doing. And what are you doing with that line? You're finding the slope. That's average rate of change. And you know slope represents rate of change, right? So what is the rate of change? We're going up to, make sure to, the numbering is good, up 2 over 4. So rate of change is up 2, rise, over 4, run, aka 1/2. That's it. Up 2 over 4, up 2 over 4. Yeah, boom, done. 18, quadrilateral, Okay, we got to write this out. Quadrilateral PQR is similar to PQRS, where PQRS corresponds. Okay, measure of P is, okay, I'm going to draw out let's draw out these guys, just so it's not, doesn't look like a rectangle, whatever. It's not saying it's a rhombus, but hey. So we got PQRS, and then we got P dash Q dash. You don't have to go this detail. I'm just doing it for your benefit. And saying the measure, and they're similar. That means the angles are equivalent. The measure of P is 30. That means P prime is 30. And the measure of Q is 50. That means Q prime is 50 because it's corresponding. It says P corresponds to P prime, and etc. And the measure of angle R is 70. So these two down here are 70. The length of each side of PQRS is 3 times each corresponding side. So if this is X, this would be 3X. If this is Y, this would be 3Y, etc. Okay, what is the measure of angle P? Now, we already said it. P prime is 30. Why is it not 90? Because when the sides are tripled, for similar figures, the angles do not triple. The angles are identical. So it's the sides that might have a scale factor. Angles are exact same. So 30 is the winner. Boom, done. 19, the given function, hold on. The given function of a perimeter, rectangle length x and fixed width. Okay. I already know what this is. Okay. So here's the dealio, right? Let's actually draw this out because it will still help us. So it's saying with the fixed length of x, a length of x and a width of whatever it is, w, right? And to get perimeter, we'd say 2x plus 2w, right? 2 times length plus 2 times width. Now, if you notice, we have the 2x in there, but what do we have? We have a constant, which means that 2w is or equals to 244. Now we got an equation. Now you solve. Divide both sides by 2. We got 122. 122 is the winner. Wait, let's just make sure. Length of x, so it's 2x, boom, boom. And fixed width, 122, 244. Yep, it's good. Boom, done. Number 20. We got plenty of time, so we're doing great. The function f is defined by the given equation for which of the following values of f. Wait. For which of the following values of k does f of k equal 3k? F of k. I get it. So all I'm doing is I'm saying the function value is 3x, when it's x. Basically, for what value of x can I plug in to get triple my input? And this gives us a nice equation. By the way, that's not a 159, that's an absolute value. Let's make those thicker. And we got an absolute value equation. Now, we can do one of two things. We can plug and chug, or we can do it the good old-fashioned way. I'm going to do it the good old-fashioned way, and then we'll plug and chug the correct answer once we get it. So first, we split it for one of these equations. The first one, we leave it as is and just remove the absolute value. Second one, we negate one of the sides. Let's negate the left side. I have a hunch this is going to give us the solution we want, but let's solve both. So I'm going to add 2x to both sides. We get 5x equals 59. Then we're going to divide by 5x equals 59 over 5. Well, actually, that is the answer. But yeah, let's keep going. This one, I'm going to add... Yeah, I'm going to add 2x, and we get negative x equals 59, which means x equals negative 59. So they don't have negative 59 here. They only have this. And how can we verify it? Okay, we can go like this. So if it's 59 over 5, let's plug it in. We should get when you plug it into that function, you should get, what is that? 3 times 59 over 5 is 150 plus 27, 177 over 5, right? Let's see. So if we do, which are the following values of k? So absolute value of 59 minus 2 times 59. But that doesn't make sense. Wait, that doesn't make sense. How would that be? Wait a minute. What is 59? I guess it does make sense because it worked, but hold on. Yeah, it's 3 times. 3 times 11 is 33. 3 times 0.8 is 2.4. You add them together, you get 35.4. Oh, it worked. Okay. Sorry. I don't know why that just threw me off for a second, but it's right. Okay. Oh, by the way, next, if we go back, what you could have done is literally just done what I did with every value, right? You plug it in. There's my, you could make this like A or something on Desmos and like plug in different values until you get triple A, right? You could plug in, like here, watch. If I plug in 3, do I get 9? No, I get 53. Plug in, I don't know, 59. Do I get 3 times 59? No, I get 59. So that you get what I'm saying? So you can plug and chug like that. Okay. 2 problems left. We got plenty of time, but these ones are usually really hard, so I like to have extra time. Triangle ABC. Draw it out. Right triangle. Like it. Boom. Oh, God. That's so bad. Let's do a better job here. Boom. Let's make it black. 1 second. All right. Not that yours has to be this precise on the test day, but just make it look nice for you guys. So we got a right angle at B, and then it says BD is an altitude. Hold on. AB is 15, and AB is 15. AC is 23. And then BD is an altitude. So that would probably, here, let's do that in red. Altitude means it comes from the vertex and is perpendicular. So it means it forms another right angle here. Hold on, let's make this clear. 23, 15. All right, what is the value of BC over, oh, that's D. Okay, hold on. Okay, B, here, let's highlight it. They want BC over BD. Okay, so what this is this is means proportional right triangles. The bottom line is what you need to recognize when you drop an altitude like this, you create 3 similar triangles. 1, 2, and the big dog, 3. They're all similars. What that means in trig is if I want, what did they say? They want BC over BD. So it's BC over BD. So it's the red over the blue, which is in this little triangle. What is that? It's hypotenuse over big leg. Well, I don't know that value, and I don't know that value. I can maybe figure them out, but instead, it's equivalent to hypotenuse over big leg of the big dog, aka 23 over 15. So that's how you do it. Let me just see if there's anything else that I missed. BC. Yeah, I think our drawing's good. I think we nailed it. So I think we can feel confident about that. And 22, I think this is the last one, right? Yeah, this is it. All right, we got plenty of time. Even if it's really hard, we should be good to go with 14 minutes. In the given equation, A and B are positive constants. The sum of the solutions to the given... Okay, stop. Sum of solutions. I always talk about this in the formula sheet. What is the sum of solutions for a quadratic, which this is, because the highest degree is 2? Negative B over A. Okay? It might look familiar. Negative B over 2A, right? That's the vertex, but it's negative B over A. That makes sense, right? Because... negative B over 2A, well, wait, hold on. Does it make sense from that perspective? Yeah, okay. So it kind of makes sense if you can think about it like this. If you have negative b over 2a, that's the vertex, and then the solutions are going to be symmetric about it, right? And so if you're, wait, actually, hold on, let me show you another way. Let me show you a better way to make sense of it. The reason why this makes sense is because it's derived from the quadratic formula, okay? Negative b plus or minus b squared minus 4ac. So there's two versions. There's the positive version and the negative version, right? So if we split it up, I'm only doing this because I know we got the time, b squared minus 4ac over 2a. If you add these together, the sum of solutions, these cancel out. Common denominators gives you negative 2b over 2a, hence negative b over a. That's the derivation of the sum of solutions. And you don't need the formula if you just want to calculate the solutions, which you can do, which would be a pain, but it's a really nice shortcut, and they test it all the time. Okay, so let's bring this over here, and I'm going to label this with the AB so you know what's what. So this is a in front of the x squared. This is b, which is negative 16a over 4b, and that's c, ab. Anyways, so they said the sum of the solutions to the given equation is that. So I'm going to also get the sum of the solutions by saying, and b is already negative, so negative b over a is just this as a positive 16a plus 4b over 64. That's negative b over a. And they're also saying the sum of solutions is, so this value is equal to k times 4a plus b, like this. Now we got an equation. That's all we need. Now we can solve. Now I'm going to, let's see, what should I do? Multiply both sides by 64, I guess. Wait, is that the best thing to do? No, this is much easier. Okay, 16 over 64, that is 1/4. So that's a over 4. And then 4 over 64 is 1/16, right? 1/16 b, or just b over 16, whatever. Here, let's do it like this. And that equals this, which is 4ka plus bk. And if these two are equal to each other, let's simplify that, because you can take either one now. A over 4 equals 4ka, and we're trying to solve for k. Divide both sides by a, boom, boom. So I have 1/4 equals 4k. Divide both sides by 4, k equals 1 over 16. Plug it back in up here. If k is 1 over 16, let's put that in before I forget. If k is 1 over 16, right? If I distribute that, I get a over 4 plus b over 16, which is the same as this, right? 16a over 64 is a over 4. 4b over 64 is b over 16. Verified, done. All right, that's it. Let's see what we did. Okay. It usually takes a second to generate this, so I'll see if we can take any questions here. All right, let's see if this works. What is this? Excellent. Oh, hold on 1 second. Let me go like this. I'm going to bring it down here and do it. 1 sec. Sorry, let me check the questions here while I do this. Wait, I missed something? Uh-oh. I hope I didn't get something wrong. I guess we'll see. Okay, I got it. Here, let's see how I haven't even looked. Let's see if I did okay. What the heck? Are you joking? Did I get stuff wrong? Oh no, wait, what? September. Oh, that's a different one. That's when maybe I did with the student. Yeah. Okay, it hasn't loaded yet. So this is September 27th, it should say. Yeah. Hold on, give me 1 second. Let's try and refresh. Yeah, because I don't think I made any mistake. There was that one question that was potentially incorrect about the margin of error. That was the only one. Here, let's see. Here we go. Wait, I got stuff wrong? Oh, no, that's right. I forgot. 760 is the max. I forgot. Yeah, it should be 100%. What? Okay, let's take a look here. Okay, the reading and writing I skipped. I got something wrong. Okay, well, there you go. I guess one wrong still gets you 100%, or a perfect. What? I missed one? I missed 21? No. Oh, wait. How do I review that? What? I got this one wrong. I was so confident on this. Wait a minute. What did I do? Hold on. Let's go over it. It was D. Oh, God. I didn't read it right. You see? I don't know if you caught it now. My bad. I'll show you. Just a reading mistake. Darn it. Oh, it just went away. Hold on. I see it. Wow. Sneaky. Very sneaky. I like that, though. I like that they did that. That's one to look out for, and that's a good mistake because hopefully that will train you guys like this is something that they might do. So look what they did. So good. Okay, here. Let me redraw it. Okay, 1 second. Okay, but at least that margin of error question was good. I mean, like I said, I felt pretty confident, but then I was like a little bit of doubt. All right, so we have B, what did I say? A and C, right? So this is so good. So what they did is they said the length of AB is 15. The length of AC is 23. I didn't read the rest of it. 23 greater than AB, meaning it's 38. Okay, and then it's the same thing after that, right? We dropped the altitude, and they wanted because that altitude meaning the definition of altitude is perpendicular. So then they wanted the value of BC hypotenuse over BD, which is the long leg. So hypotenuse over long leg. So it's 38 over 15, not 23 over 15. And they put it there just to be tricky. So that's pretty cool. So one thing that I'm noticing on this digital is, you gotta be extra careful on the reading, and some of the ways maybe we would read the previous test aren't gonna connect. Okay, there we go. Hey, it's morning. It's afternoon here. It's noon here right now. What's up, Sushil Kumar? And well, I hope you guys found this useful and helpful. Next week, we're going to be doing more more SAT prep for the October SAT. I'm going to be doing one more PSAT later in the week as well. And a lot of people are probably taking it next week or in the next couple of weeks. So this will be out there for you to use and to study with. And that's that. So thank you guys so much for joining. Please click that like button if you did like this video. And make sure to subscribe if you want to see more from Scalar Learning. And by the way, check out the link below if you do want to check out SAT Crash Course. I highly recommend it. Thank you guys so much for joining.